Hello and welcome to Rajya Sabha Television's special presentation on India's fight against COVID-19. Here we bring you all the details of several aspects of the challenges which we as a country and a society face and the solutions which are being brought about by the corona warriors in the form of health workers, in the form of researchers, scientists and others involved as well, whether it is through technological interventions or other aspects. And today we will talk about a very important subject, and that is the test kits, the testing kits for COVID-19, and specifically one testing kit which has been indigenously developed by our own researchers and scientists. And this testing kit has been named as a FELUDA testing kit, that is FELUDA. And this testing kit is considered to be very fast, efficient, accurate, and much cheaper than the RT-PCR kits as well. We will try and understand what exactly is this testing kit and how was it developed. And for this, we have two very important guests with us, none other than Dr. Debojyoti Chakraborty, who is part of the team which worked on this testing kit and developed it as well. He is a senior scientist with CSIR's Institute of Genomics and Integrative Biology. Welcome, Dr. Chakraborty, to Rajya Sabha TV. We also have with us Dr. Rakesh Mishra. He is the director of CSIR's Center for Cellular and Molecular Biology. Dr. Mishra, welcome to you as well. Let me begin with you, Dr. Chakraborty, and for our viewers' sake, let's try and understand, and let's start with what exactly is a FELUDA test kit, because one point here attached with this test kit is that name specifically FELUDA is the name of a character in one of the well-known movies as well.
Yeah, that's right. So thank you for inviting me in this panel. So I'll just give you a brief, some kind of a background about what FELUDA is about. So the work on this developing a testing, a testing assay which could detect DNA or RNA or nucleic acid mutations was not done in the last 2 months or 3 months. It had actually started almost 2 years back, and we were developing something for the sickle cell anemia as a part of the CSIR sickle cell anemia mission mode. And the strategy that we wanted to use there was to use a combination of the CRISPR biology, CRISPR Cas9 biology, and then adapt it using different kinds of readouts. And one of them was actually the paper strip readout. So paper strip chemistry combined with CRISPR biology. And then in January, when the COVID-19 pandemic had just started, we figured out that this could be very well purposed for the COVID-19 detection as well. And about the last 3-4 months, we have been working very hard to try to repurpose it for an early and a quick detection for COVID-19. Regarding the name, so we are using a CRISPR Cas system, which actually is, from a very extensively characterized Cas system that we have done at CSIR IGIB. It's a Cas9 protein from Francisella novicida, which is being used as the protein for detecting COVID-19. Now, there are two other types of detection strategies that have been popularized by MIT as well as University of California, Berkeley, using the Cas12 and the Cas13 systems. And these were named as Sherlock and Detector. So when we decided to, name our technology, we thought that we should have an indigenous name of a detective, and that's how the FELUDA name came about. So it's an acronym. The full form of it is FN Cas9 Editor Linked Uniform Detection Assay. That's the.
Okay.
That's the
Okay. So FELUDA does have a scientific, detailed explanation there as well. But you pointed out the reason why you chose to have that particular name from the movie character. One aspect here is again, it's also being said by the experts and read in the news reports as well that as far as FELUDA test kit is concerned, it's very cheap and it's very efficient as well. So what are we comparing it with? The RT-PCR test kits when we say that it is cheaper?
Right. So the gold standard RT-PCR kits is what currently all tests are being compared with. On an average, these come close to 4,500 to 5,000. It varies a bit. From our lab level calculations that we have done for every assay of FELUDA, which costs close to about 500 to 600 rupees. So it's several fold lower than what is the current market price. But you have to realize that we at CSIR IGIB, we are an academic academic institution, so we are not really making the kits per se. This is would be done by industries, and very recently you have heard about the agreement with CSIR and Tata Sons, who are going to take up FELUDA for mass deployment. So the final pricing would be actually determined at that end.
Okay, final pricing would be determined at that point. And we'll talk about the mass testing strategy and how it might be useful there as well. But let me first bring in Dr. Mishra here. Dr. Mishra, from your point of view, in terms of various testing kits which have come in the past 5 to 6 weeks, or even more than that, since we have faced the COVID-19 pandemic, how would you look at this indigenous, test kit, the FELUDA test kit, and the technology it uses, the CRISPR technology, as Dr. Chakraborty pointed out?
Yeah. So, as you just heard from Dr. Chakraborty, that is a new approach to detect a DNA or RNA in a sample that you're looking for. So, this can be actually useful for any DNA, RNA based diagnostic that you want. So, that is, it's not only just for COVID, but COVID, because this is urgencies, we are talking more about it. And I'm sure this will be employed for many other DNA-based diagnostic, which is becoming more and more popular. So that is one thing that is very general thing, very useful thing that is come out. As you heard, that the effort to make such a kit was going on for some time. The other thing is very simple, that we have one more arsenal in our arms to fight a pandemic. Right, so it's always better. Some places certain kits are more useful, some places some other kits are more useful. This one is particularly very sensitive, and as you just heard, less expensive. Very sensitive because it is looking for a DNA sequence, or it can be also RNA sequence. And once it finds even few molecules, then a sleeping protein becomes a catalyst. And then it starts churning out signal, because you provide it something which will, if you eat up, then it will create a signal. So a very few molecules of DNA, RNA that are your target, which are eventually a virus or something, then you are going to pick that very, very sensitive way. So it's very important. I'm sure it will be very useful for COVID, but it will have much more implications later on for many other diagnostics, one of the advanced ways of doing diagnostics in all over the world.
Okay, so it is not only going to be useful just in COVID-19 pandemic, but as Dr. Mishra is pointing out later on as well. For our viewers' sake, Dr. Chakraborty, in terms of, for the layman to understand, for example, an RT-PCR test kit works in a specific way. So does other test kits which are there in the market, the antibody test kit as well. So when we talk about the FELUDA test kit or the paper strip test kit, how does it work? As in scientifically, yes, Dr. Mishra has also pointed out, explained, and you had also earlier said. But from a layman's point of view, if as a patient or as a person, I am administered a FELUDA test kit, how will it work?
Right. So this is a diagnostic test. So it is not an invasive procedure or any kind of administration-based application. So there are two types of tests which you might have heard about already. One is a nucleic acid test, and another is an antibody-based test. So the rapid tests are the antibody-based tests that basically is measuring the body's immune system's response to an invading or a virus invasion, whereas a nucleic acid test is directly detecting the viral load in the sample. So in this case for FELUDA, it is a nucleic acid test, which means that it tries to detect if COVID-19 DNA or COVID-19 RNA is present in the sample. So the start or the workflow starts from the RNA, which is extracted from the patient's cells, and the extraction is generally happens using nasal or oral swabs and sometimes even saliva. And then once the RNA is extracted, and this RNA might contain the COVID-19 sequence RNA as well, or it might not, based on whether the sample is positive or negative. So how this CRISPR technology works is that the main component of this technology is a Cas protein or a Cas9 protein, which almost acts like a barcode. So if you tell it that it should find this particular sequence on a nucleic acid, then it will go and specifically find that, and then it will form a complex with that. So in this case, we are actually converting the RNA to DNA to make it more, to make it susceptible to Cas9 activity, and then we are amplifying the DNA in many copies so that we increase the number. And this process is known as reverse transcription PCR. So this is different from an RT-PCR test, which people are doing, which is a real-time PCR. Okay. So this reverse transcription PCR makes a number of copies of DNA. And then the Cas9 is given the instruction that you go and find the COVID-19 sequence on that DNA, which it does with very high efficiency and specificity. And once it goes and does that, it goes and interacts with the DNA and forms a complex. And this complex can then be put on a paper strip. It goes up the paper strip through, lateral flow. It basically moves up the strip, and then it gives a single line at a test line, which tells if the original sample had COVID presence or not. And then there is also a control line in the same strip, which tells if the strip is working or not. So it performs very similar to how a pregnancy kit does, which are used in the market. And this also has to, control and a test line. So the similar way the strip also performs. So if there is a control, if the test line is positive, then we can say that the patient was positive. If the test line is negative, then the patient was negative.
Okay, and let's talk about the the mass deployment or the mass testing which might be possible with this, which you were earlier referring to. Obviously, cost is one aspect of it, but I believe the other aspect and very important aspect here is that you don't need big machines or heavy machine or equipment out there to be taken to the interiors or the rural areas. This is since paper-based test, it can easily be carried anywhere, and the accuracy is also very effective.
Yeah, so our whole aim was to make this test available and usable at a very basic level, which is not a high-ended laboratory, but rather at a pathology lab or at a university, at an Anganwadi center or a local health center by people who are not exceptionally trained in following biology protocols. It is not yet a home test, but currently we need a very basic form of a PCR machine, which is the only complex instrumentation required. But in our next version of the test, we will be hopefully able to eliminate even that requirement as well.
Okay. So that's very interesting and important out there. Dr. Mishra, I'd like to come here to you on this particular aspect only. This kind of test, which does not require, equipment or machinery be transported from one place to the other, and the faster rate of giving the results, the cheaper as well in comparison to the other test kits. This is what gives us that fillip in terms of continuing with the testing strategy, which we were earlier talking about, and so far was not possible.
Right, exactly. Yeah. So, we not need a RT-PCR machine, which is a sophisticated machine that requires more training, and of course very expensive machine. So many people don't have it. Even abroad labs for testing, they had to assemble machines from various places. So this liberates you from such limitations, and then now you can go, as Dr. Chakraborty mentioned, to primary healthcare centers or in one centralized place in the village at Anganwadi, in those places. So that means we are taking tests to very point of care sense, and then you can then increase the large number of people who come in the cover of this technology. And because you are carrying paper-based things, so you will have less logistic nightmares of carrying lots of things in a minus 20 degree or frozen conditions and so on. This will also require some of those things, but much less degree, so it's a more manageable thing. So these are the technologies. You see, the CRISPR is technology, how bacteria defends itself from when it is attacked by viruses, they call bacteriophages. So now scientists are using this technology to go and edit genomes. Now here what scientists are doing is taking this advantage of the enzyme because it can read specific sequences and going and using it for detection. So it's a very good example of very sophisticated, good science leading to a technology that will have tremendous societal impact. So I'm very, very happy that it has come at the right time when many people are looking for something to help in this pandemic. And I'm also sure that it will not only be helpful for this pandemic, because for obvious reasons that it can go to smaller places. And more, equally important is that large company like Tata Sons have agreed to take it up, which means they will have resources and and logistics to take it to large part of the country. That's very important. Many good technologies stay home because there's nobody to implement it. So I think IGIB has done great job in finding a good partner, industry partner, because we can only do science, we can generate technology now, but after that, to take it to people, large scale production, scaling up, all those things are something capable, and a specialist should do that. So I think that is another success that has been added to this good technology, and I'm sure it will have its impact right now and also in future for other DNA-based diagnostics that are becoming more and more common all over the world. And in India, it's now very frequently used in many places.
Okay, definitely. The commercial aspect of it, which you mentioned, Dr. Mishra, is very important aspect out there. And that MOU signed with Tata Sons is the one which will bring it to the field and to the people who need it the most. And what we are being told is that this should happen by the end of this month. It should. The commercial production should happen. Let me go back to Dr. Chakraborty here. Dr. Chakraborty, the most important point here is the fact that this is indigenously developed. And since you and your team worked on it all this time, what we would like to understand is that how difficult or easy was the entire process, and what were the challenges which you had to overcome, specifically in a situation where it's a pandemic situation and you have to, or rather you would want to go ahead and have positive results.
Right. So so this work was actually done together with Dr. Shobhik Maiti. So we are two people who have a group of people, students and project assistants and postdocs who worked on this. And like I said, we were doing this for the last 2 years. And like in a regular life of a scientist, almost 95% of the times we are wrong. So we have a very low success rate on a day-to-day basis. So the challenges are just too many to actually even enumerate. But all I can say is that we have a very motivated team, and currently you did mention the indigenous development. I must clarify over here, the CRISPR diagnostics is not something that was not known. So CRISPR diagnostics has been there from the MIT and the Berkeley groups using different proteins. What we figured out was that we a protein that we had extensively characterized over the last 2-3 years could do a very good job of actually identifying even point mutations in DNA. So is really now. I mean, everything is very good at the lab level. When we take it for a diagnostic to the field, then a lot of other things come in, and one of the things that we want our system to be as accurate as many number of times as possible. And for that, I think the students who are working on this, who have actually stayed back during the lockdown and over the last 2 months, they have been working day and night, modifying small components of the entire reaction to try to find out with what accuracy we can actually take it. And I'm quite happy with the way that they are with this, the way the progress has happened there. And our main challenge now is to make a product which would really be able to serve people to the best possible purpose. That's our major content.
Okay, that's quite interesting. The entire journey, and then the fact that out there as well. Dr. Mishra, continuing this further, in your view on this part in terms of the indigenous work being done by Indian researchers, Indian scientists during this COVID-19 pandemic, during this fight, and we have had a word with you on this particular show on other aspects earlier as well. So this also brings in focus the fact that our laboratories, our researchers, our scientists do have that in them to go ahead and face all these challenges and find the solutions there. It's just a matter of time, and when the results are there, to back it up with the industry support.
Right. You correctly mentioned it that in times of difficulty, in times of pandemic, when people have looked towards research institutions, I'm proud to say, have responded really with extraordinary courage and dedication. Now, almost all the country, there is no research activity happening, but all those institutes are functioning. They are functioning because they are doing something to help in the COVID research. One example, you see, this is actually the ideal thing to come out from a research institution, where you are doing science, when you are discovering technology, and when need comes, you modify the technology, adjust it so that it is useful for the people. See, research is a difficult activity. You are looking for something which is not known at all. So the chances of success are less. But when you have success, when you are smart, you convert into something useful. So that has happened. That's the perfect example to give. But research institutions, including IGIB and many other CSR institutes and other institutions in the country, have been making sanitizers, making food packages, carrying out tests themselves, and responding to the need of the hour. So I think we have, as a community, taken up this challenge to show that we are capable of handling sophisticated technologies and handle dangerous bugs like COVID-19 virus,
COVID-19
and
virus.
also come up with the new weapons, new ways of fighting it that gives us more confidence and more enthusiasm to face such troubles if they come ever in future as well.
Definitely, definitely there. Thank you so much, Dr. Mishra and Dr. Chakraborty out there, as pointed out by both of you. And this test kit being developed indigenously, also one more feather in the cap as far as India's research or scientific community is concerned. And they have done their bit, faced up all the challenges, come up with solutions, still working on them, as Dr. Mishra was pointing out, to find the solutions to this particular problem and how we can defeat a coronavirus or tackle COVID-19 pandemic. So this was the sum up of what exactly is a FELUDA test kit and how it might be helpful in terms of going ahead with the mass testing strategy. The reason being it is cheaper, it is faster, and it is also easily transportable, or it can be carried to the interiors, be it in rural areas or difficult terrains as well. We'll come back again with a different topic. Till then, you keep watching Rajya Sabha television, keep following all the guidelines as far as the fight against COVID-19 is concerned. Stay safe, stay home, take care.